Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, we are going to consider another important topic of 8086 microprocessor, and that is segment registers. In last video tutorial, we have already learned that microprocessors memory is around 1 megabyte, right? The full memory which is available or which can be connected to microprocessor 8086 is 1 megabyte, but it was divided into 16 segments, right? For certain reason, and which we have already discussed in the last tutorial. Okay, each segment's size is around 64 kilobytes, so we know that 16 segments are possible, right? But out of 16 segments at a time, only 4 segments are active, right? This is the key word of today's lecture, right? Or today's video tutorial. So this is the point that we are going to focus. Only 4 segments out of 16 segments are active at a time, or they can actually be accessible for a number of uh, for the user and for the programmer, right? And those segments are named as code segment, data segment, stake segment, extra segment. So this is our complete memory, and in that memory we have only selected only 4 portions. Remaining 12 portions are not selected because in total there will be 16 segments, but only 4 of them are selected, and those are known as code segment, data segment, stake segment, and extra segment. Code segment is used to store the information related to the program, or you can say the program is stored inside the code segment, or code is stored inside the code segment. Data segment, data segment is like your RAM. You can actually use use it to store any data which is being manipulated, which is required to process or to complete execution of the program, right? So this section is basically our data section, right? And then there is a third segment which is known as a stake segment. Stake is an important uh, memory location or memory storage place which is required for any microcontroller or microprocessor system. We're gonna cover a separate tutorial on stake, so uh, there will be a link on in this video. You can actually go to that link and you can find stake segment in a complete detail. So this is a segment, this is a segment we are going to cover in total separate lecture, right? So the fourth segment is extra segment. Extra segment is basically supplement for data segment. Once data segment is full and you still require some storage place to put some data, so then user can actually use extra segment. So extra segment is another data segment. So one can say that 64 kilobyte, 64 kilobyte is dedicated for code or the program, right? 64k byte is for what? Stake, right? That we're gonna cover in separate lecture. And 64k plus 64k, right, is equal to how many? 128 kilobyte are dedicated for what? For data, for data storage, right? In total, if we cover them, if we count them, it is 256 kilobyte memory which is accessible, right, at a simultaneously for any programmer or any user, right? So this is one of the highlightation of this video tutorial. So we need to note it down, right? Okay, now we come to another fact. We have already covered software model or internal architecture, and we have seen various segment registers, right? So this is very first time we are using them. Code segment register, data segment register, stake segment register, and extra segment register. So these 4 registers are present in internal architecture of microprocessor, and we have also observed them in software model. So what is their function, right? uh, One thing is missing here. Let me highlight it. So their function is to store the lowest, or the, you can say, starting address of every segment, right? And before we go and explain it, we need to discuss this point. The lowest address or the starting address of every segment is known as what? Base address. What we call them? Base address. So one can say that if code segment is starting from this point, so this is the very first location. So this location is known as what? Or this address is known as what? Segment base address of code segment, right? Similarly, if it is the lowest or the starting address of data segment, so this address is basically what? Segment based address of data segment. And this is also true for state segment and extra segment. And where do we store them? These segment based addresses are stored in respective uh, data segment. It is also written over here. I have already written it. Segment register holds base addresses of respective segment. For example, data segment register will be storing what? Base address of data segment. Code segment register will hold base address for code segment. Similarly, stake segment register will hold base address for stake segment. So if I summarize it, every starting address or lowest address, right? Because starting address of will be of course lowest address as well, right? So starting address of every segment is known as segment base address or simple base address, and that is stored in respective segment register, right? Segment base address is also known as what? Current segment register values. Okay, I told you that there are in total 16 segments and we have selected only 4 of them. So, for example, let's consider this example. This is our memory, full memory, and there are various segments, right? For example, right? For example, we have chosen it, so we can choose it, we can choose it, and we can choose it. But it's quite possible you can also choose this one. So how to choose this? Basically, you need to change these values: code segment register value, data segment register value, stake segment register value, and extra segment register value. That is why these are basically what? User accessible. You change these values, that means you are changing the segment. For example, if this portion was selected as code segment, so the address of this value or address of this segment will be stored in code segment register, right? You can actually change it, right? Let me give you another example. Okay, if it is A, it is B, it is C, it is D, it is E, and there could be number of segments, right? I'm just taking few examples, A to F, right? And these are nothing but these letters are indicating segment based addresses of these respective segments, right? So for example, if one is saying that CSR or code segment register is equal to B, that means segment B segment B has been chosen as code segment, right? If I write SSR segment stake segment register is equal to F, that means segment F is our stake segment, right? So similarly, these segment register can be chosen, can be rewritten, and can be modified by user, so that these segments can be selected out of 16, right? Okay, one point that is remaining, that is still we need to discuss about segmentation, that is these segment register can be of out of these three options, right? They can be disjointed. Disjointed means you can see that this code segment and this data segment completely spaced. There is a quite far space between them, right? So that is why they call disjoint. They are not connected with each other, right? They can be overlapped. Overlap means for example, this is our code segment. It is quite possible that I can start another segment from here, and this will be considered our what another segment, right? So that means this portion will be what? This portion will be overlap between two different segments, right? So that is what it is also possible, and we will be using some of the examples in coming lectures soon, right? So this overlapping is completely allowed in 8086 microprocessor, right? Furthermore, this overlapping allows it also allows more than 16 segments. Remember, 16 segments are possible only when we are considering disjointed sets or disjointed segments, right? But this procedure, when one segment can be overlapped with another segment, that means we can actually consider multiple number of segments. In fact, infinite number of segments are possible. Okay. Okay, now we go to third specific type of segment, that is adjacent set. That's quite relevant and that's quite easy to understand. For example, in this picture you can see A and B are adjacent, B and C are adjacent, C and D are adjacent. That means if one segment is uh, completing, the uh, other segment will start immediately, right? That is what called adjacent, right? Or neighboring segment, right? So that is what the three possible scenarios for segments. They can be disjointed as they are in this example. Overlapped I discussed over here, right? So this can be overlap example, and the third example, it could be adjacent, right? So it depends upon the user or the programmer who is using the 8086 microprocessor. They can actually use it according to their specific need. Okay. I hope in this video tutorial we have learned how one can actually create segments, and how many segments can be simultaneously active, and how those segments can be chosen from various available segments, right? And furthermore, how much data is how much storage is available for data, how much storage is available for code, and how much is available for stake implementation, right? Furthermore, we also discussed what are segment register and how they are useful in controlling or management of various segments, right? If you have any question and query, you can post them in comment section. Thank you so much for listening.